Chapter 9, we're going to be talking about value returning functions. You guys have probably used functions, well, not probably, but definitely when you have taken a math class. So if you look at your calculator, you have functions that allow you to take a number and square it. So you would basically give the function a value and press the button on your calculator that squares it. That's the function, and it returns to you the number squared. So that's one function that your calculator can do. And you know, as we get to some of the more complex calculators, they have more and more functions on the calculator. So in this chapter, we're going to look at, I don't know what I did there. That's interesting. There we go. We're going to look at already created functions that C++ already has for us, and we can just use them. And then we'll also learn how to create our own functions. One of the functions that we'll look at is the power function. So that's the one that I was just talking about, where, well, there's a square root function, so you square a number, but then there's also the power function where you take a number, you tell it, like, I want this number to the power of 5 or the power of 10, and then it gives you the answer back. There's also a function that we're going to learn to generate random numbers, and generating random numbers is actually really useful in programming when it comes to creating games. So we'll look and see how to generate random numbers, and looking at how do we actually call the function in the program. So what's the syntax, the way to do that, and calling the function that returns a value. So for example, the square root function will return a value. We're going to pass information by value to a function. We'll talk about this later. Writing a function prototype, you'll understand more about that. And the scope of variables and the lifetime of variables when we deal with functions. So a function is just a block of code that performs a task. Every C++ program contains at least one function. So main is a function. Okay. And I'm just going to end this here for a second. So here's, you have a function. The name of it is main. And I know it's a function because it has an open and a closed parentheses. And this function, like I had said before, returns an integer. It has an open and a closed curly brace. Every C++ program has to have this one. We're going to be using other functions, extra functions. Some functions are built-in functions. They're already part of C++, defined in a library. If you remember, these are the libraries up here. So if I want to use a math function like square root or power function, there's going to be a library or an include file that I'm going to have to add here. Others, called program-defined functions, are written by programmers and defined in a program. So we can create our own functions, and sometimes in companies, they'll have all these functions that they've created specifically for that company, so specifically for what that company does. So let's say it's financing, you can kind of think about all the different functions that you could create and reuse so that anybody in the company can use it. They don't have to basically reinvent the wheel every time. Functions allow for blocks of code to be used many times in a program without having to duplicate the code. So definitely, if you know you're going to do this more than once in your program, whatever that block of code is, then you think, oh, I need to create a function for this so I don't have to type that block of code over and over again. Functions also allow large, complex programs to be broken down into small, manageable subtasks. So we don't want to write a program all in the main function, especially in real world programs. They're really, really big programs. So you want to break those up into different tasks. Also, if you're working in a group, in a team, then somebody might create one part of the program, so they're creating all their functions in that part of that program, and somebody creates another one, and then maybe your program calls their functions, etc. Each subtask is solved by a function, and thus different people can write different functions. Okay, many functions can then be combined into a single program. Typically, main is used to call other functions. So that's what we do in main. We call other functions. But any function can call any other function. So we can call a function within a function. All functions are either value returning or void functions. A value returning function performs a task and then returns precisely one value. For example, the power function, you would give it, let's say the number, you would give it the number 5 and then number 3. So you want to raise 5 to the power of 2, and then it returns to you 5 times 5, 25. So it returns to you the 25. That's a value returning function. A void function is a function that doesn't return anything back. So you can give something to a function, and the function can do a calculation, or maybe it prints something to the screen, to the display screen, or maybe it saves some data into a file, but it doesn't return anything from the function. And then the built-in functions that we're going to look at is power function and the square root function. So the power function raises a number to a power and returns the results as a double. The way we call it is we say POW x comma y. X is the base. So let's say we want 5 to the power of 2. So the exponent is y and the base is 5. At least one of the two arguments has to be a double. So either the x has to be a double or the y has to be a double. So you could pass it 5.0 and 2, or a 5 and a 2. And then it's going to return back to you a double, and you'll have to include CMath for this, for the power function to work. And we'll look at some examples in a little bit. So here's power radius is 5.0. So that's a double. That's an integer. So it'd be 5 squared. So 5 times 5 is 25. And so 25, whoops, this becomes 25, and then it gets multiplied by 3.14. The square root function is a built-in value returning function that returns the number's square root as a double. Definition is also in the CMath library, so you also have to include CMath. All you have to pass it is one number, and that number has to either be a double or float. And then what this will do is the actual arguments are passed to a function when called, and then it's going to return back to you the square root of the number. So for example, if we take and we pass it 100.0, it returns back a 10, because 10 times 10 is 100. And that 10 that it returns in this example gets assigned to this variable. So we define square root variable, and square root equals square root of 100. The square root then becomes 10. Here we ask the user to enter a number. They can enter any number. Num is defined as a double, and then this will see out or output the square root of that number. So we're going to take a look at a program example, and this program is going to calculate and display the length of a right triangle's hypotenuse. So we're going to use the Pythagorean Theorem, and this theorem requires squaring and taking the square root of a number. So we're going to use the power function and the square root function, both of those. So the Pythagorean theorem, if you remember, states that the length of a triangle's hypotenuse is equal to the square root of the sum of the squares of the lengths of the triangle's two adjacent sides. So it looks like this. This is the hypotenuse right here, and this C is equal to the square root of the sum of the squares of the length. So a squared plus b squared, and find the square root of that. So a squared plus b squared, a squared plus b squared, find the square root of that. That's going to equal this right here, which is the hypotenuse. Okay. I think this is our right there. So an example that they give you is if you have side A is 10 and side B is 10, it says, oh no, I'm sorry, so side A is not 10. What are the sides? Side A, so side A is 10 and side B is 24. So you get 10 times 10, that's side A, 24 times 24, that's side B. You take both of these and you add them up, so it's 676. And then you take the square root of 676, and if you type that into your calculator, it comes out to 26. So I'm going to pull my calculator out, and I'm going to try that out. So anytime you look at stuff like this, you want to make sure you understand the problem fully and you test it out on your using a calculator. So I just typed 676. Let me do it here so you can see it. So 676. And I wonder if this has, I'm not sure how to make this bigger. Large type, there we go. No, that's not what I want. What's this? Okay, so on my calculator, it's a lot easier. So I actually to turn mine sideways. So I have an iPhone and I have a calculator on my iPhone, and it should be just like this. I'm just not sure how to use the one on the computer. And I turn it sideways and it gives me all kinds of functions. So for example, I'm looking at, I have the function where I can take a number and square it cube it, or I can raise it to any power. So it'll be x to the power of y. I have logarithmic function. I have all kinds of things. So on here, I have the square root function. And what it looks like, it has a little 2 on the outside. It has the radical, and the radical is this sign right here, and it has a little 2 right here, and then inside here it has an x. That's the button that I want to use. And the number that I'm looking at is 676. So the first thing I do is I click on the function, and then I type in 676, and I get 26. And I'm sorry that I can't show you that with this calculator. Just not sure how to use it. Okay. Well, I'll look at that later. So what we've done first is we've included CMath. Remember, IO stream is included, so you can use C out, C in. IO manip is used to manipulate output. We'll look at that, see how they must be using it here somewhere. Let's see. Yeah, see right here they use set precision 1. This function here is used with IO manip. So it manipulates the input and the output. And then this is for math, requires for the POW and the square root function. Then we're going to add using namespace standard. This is so that we can also use C in and C out without using STD before it. We define some variables, side A, side B, sum squares, hypotenuse. We ask the user to give us side A, give us side B. We take side A and raise it to the power 2. We take side B, we raise it to the power 2, so they're both squared. We add those, and we get the sides, the two sides squared. Then we want to find the square root of this number, and that gives us C, side C, which is the hypotenuse. And then we output the hypotenuse. But before we do that, they did set precision 1. So what that does is it, whatever number you get, it gives you one number after the decimal. So set precision 1 will give you just one number after the decimal. Some other functions that are included in C++, it has a ton of them, but these are some that we're going to be using in some of our programs, is the rand function for randomizing, srand also for randomizing, and these are used together, and then the time function. C++ provides a pseudo-random number generator. It produces a sequence of numbers that meet certain statistical requirements for randomness. Numbers chosen uniformly from a finite set of numbers, not truly random but sufficient for practical purposes. So the random number generator is called rand. It returns an integer between 0 and rand max. Rand max is a built-in constant that is greater than or equal to 32,767. To call the rand function, you just use rand, open and close parentheses. You don't need any arguments, nothing has to be passed to it, but you still need the parentheses. So we have a formula here. This formula allows ranges other than 0 to rand max to be used. The range is upper bound to lower bound. So we have lower bound. So let's say that you just want a number between 1 and 100. So if you want it between 1 and 100, your lower bound would be 1 and your upper bound would be 100. Initialize random number generator each time, otherwise it's going to produce the same sequence. So we have to, if we don't initialize the random number generator, then every time you run the program, you're going to get exactly the same value. So if the first time you run it, you get a 3, the next time you run it, you're going to get a 3, the next time you run it, you're going to get a 3. So here's an example using the rand function. We have integer random num equals rand. So let's go ahead and do that. Let's type it into a program. So if I don't using namespace standard, then it requires me to add this in front of every line, cout, cin. I'm going to go ahead and add my pound include, and the pound include is for using, no, I'm sorry, not pound include, using namespace standard. Trying to see what the include file is for rand and srand. Okay, well let's try it and see what it does. So integer x equals 0, x equals rand, cout x. Okay, so it doesn't require to use rand. You don't need a specific library other than your standard input output stream to be able to use rand. So here the number that we get back is this big number. So I'm going to run it again. And notice that I get the same number again, 180, and it ends in 83. 180 ends in 83. It's the same exact number. So what I have to do is I have to change the seed or change where I want it to start. And here's how we're going to do that. We'll look at the boundaries in just a second if we wanted to go like just randomize like 1 to 10 or 1 to 100. Here we go. So srand function initializes your random number generator. For srand, you're going to pass it a seed in which the seed is an integer actual argument that represents the starting point of the generator. We commonly initialize using the time function. If you use the time function to initialize your random generator, that it ensures a unique sequence of numbers for each program run. So every time you run the program, it's going to be unique because when you get the time, you're going to get minutes and seconds, and it's going to be different every time that you run it. So an example, the time function, it says it's a value returning function. It returns current time in number of seconds since January 1, 1970. It returns a time t object, so must be cast to an integer before passing to srand. Talk about that later. Program has to contain c time to be able to use it. And here's an example. So they have x equals 0. It has to enter an integer. Let's say we enter the integer 5. We call srand 5. We see out random. And it says that the srand function initializes the random number generator using the integer entered by the user. The cout statement displays a random integer that will be greater than or equal to 0, but less than or equal to rand max. So let's try that one first to see what that does. So we're going to call srand here. Enter an integer, cin x, srand x, make this y since we used x. This is another way to define variables, is by using a comma in between them. So if x and y are going to be integers, you don't have to say int x, int y. You can just define all your integers in one line, and they all get initialized to this number here. Okay, so this error right here says that it says expected semicolon before y. So if I put my arrow there, it said expected semicolon before y. So here's y. Before y is here. So I left my semicolon out right there. So if I enter the integer 5, I get 59001165. If I enter 5 again, I get the same number, 59001165. Now if I enter 7, oops, then of course it's going to give me a different number. 8, etc. So on this one, you're changing the seed, but you're changing it by the number that the user is entering. So if they enter the same number, then they're going to get the same random number. So it doesn't work as well, but you can use it that way. The other way that they show us here is by using the time function. So it says the time function requires the pound include ctime directive. Let's put that there. Before we do that, let's do that. And then we're not going to ask the user to enter anything. We're going to use srand. Inside srand, we're going to say static cast integer time 0. So here is where you're calling the time function right here. This is where you call the time function. And it said in our slides that the time function returns a time t object, but we can't use an object for this sran function. For sran function, we can only use an integer. So all this does here is it converts what this returns, it converts it to an integer. I guess you could think of it like, I'm trying to think of an example. Well, basically it would be like if I gave you, I don't know, you required a certain key for your house, but I gave it to you in the wrong format, you would have to change it to the right format for it to work on your door. I don't know. I really can't think of an example, but it's the best example I can come up with right now, just from the top of my head. So it's basically taking whatever this returns and changing it into an integer. So this returns something that's not an integer. But srand requires you to pass it an integer for it to work. So that's why they're doing this right here. So we have the static cast integer. And then now we have y equals rand, c out y. So srand, c out rand. And all that does, remember all this is doing right here is initializing where we're going to start getting our random number. So it's going to just initialize it to something different every time because it's using time as the value. All right, so let's take a look at, this is a warning. It's telling me that X is defined and not used. That's not a big deal. It's still going to work. But let's take a look at the error. So the error says static cast was not declared in this scope. Oh, I misspelled static. I put static. Okay. And the next error says expected parentheses before semicolon. So it looks like I'm missing a parentheses. So I've got these two parentheses here belong to time. This two parentheses belong to static cast and then I need one more parentheses that belongs to this parentheses here belongs to this parentheses. Okay, so it gave me, so this is what I was thinking. In here it told me that it needed C time for it to run, but it doesn't look like it needs C time to run. It looks like this is defined in an IOStream. So for this particular compiler, I don't need to define C time. So every time I run it, I'm going to get a different number here, different number. Okay, the last thing we're going to look at when using random numbers, generating random numbers, is that maybe you don't want this huge random number. So in this particular example, we're looking at the assignment statement assigns a random integer that is greater than or equal to 1 but less than or equal to 10. So it's just going to give me a random number between 1 and 10. And maybe that's what you want. Maybe you're playing a game and you need a number between 1 and 10, or a number between 1 and 20, or 1 and 100, or whatever it is. So we would add random So right here, we would say 1. So this is my lower, I want a number between, let's say, 1 and 100. So I'm going to say 1 rand percent. This is my upper bound. And rand. Okay, so that gives me 84, 71, 5. So I'm between 1 and 100. Now if I go to 10, 8, it's not going to get past 10. There's 10. So it's giving me between 1 and 10. Okay? And you'll use this function several times, especially later on in your program when we create some games in some later chapters. So here they're just saying they have a guessing game, and the guessing game generates a random number between 1 and 10. So this is what we just did. We generated numbers between 1 and 10. You can look at this on your own, look at all the code for the guessing game. The next thing that we're going to look at is defining our own functions. Okay, so I'm going to go ahead and just show you an example of how to define your own functions. Then all the information I'm going to talk about is here in your slides. So I'm not going to read all this to you, because if I read it to you, it's not going to make sense. I'm actually going to start with an example and give you all the information that you ever needed to know about value returning functions. So let's say that I want to create a function that is called generate random number. Okay, so I'm going to take this and I'm going to make it into a function. Okay, and the function name is going to be generate random number. So when I create a function, I have to create the function outside of main. So I'm going to delete all this here. Now this function returns a number between 1 and 10. So I wanted to generate a number, and I wanted to generate a number. I wanted to tell me the lower bound and the upper bound, but it returns an integer. So I'm going to call my function random num generator. That's the name of my function. And I want to know what the lower bound is, lower bound and upper bound, so that all you have to do is say, okay, give me a number between, when you call the function, this is what it should look like. It should be like integer random num, and when you call the function, it would say random num equals random num generator, and then the user could enter anything. The user could say, oh, I want a number between 5 and 15, or I want a number between 1 and 10. But all they have to do is call this function called random number generator. Okay, so this is a function that we're defining, we're creating, and it's going to be, all the code's going to be in here. So this is the code that we had earlier, and all the code has to be inside an open and a curly brace. open curly brace, close curly brace. So this is a function that I defined. This is the main function. And I'm going to call this here is where I'm calling the function. This is called function definition. Okay, and I haven't done everything yet. I have to change this a little bit. So here, instead of, so if we looked at, let's go back to here. If you remember when we talked about so when we talked about how to generate integers, we have lower bound, we have rand, percent, we have upper bound minus lower bound. Upper bound minus lower bound plus 1. Okay, so here we're going to do that. We're going to put lower bound, upper bound, lower bound. This variable is the variable that gets passed to the function. This variable is this variable that gets passed to the function. This variable is this variable that gets passed to the function. Notice when I highlight this variable, it automatically shows me where the variable is defined. Okay? When I highlight y, it shows me that y is defined right there. Now, instead of seeing out y, I don't want to see out y. I want to return y to here. So whatever this gives me, the random number, it gets returned and stored in this variable. So here what I'm going to put is return y. So y is an integer. This here means that I'm returning an integer. So the data type for this has to match this or has to be something higher. So I could put here double and return an integer, and it would change it and return a double here if I wanted. So if I have integer here, most likely I will have an integer there. If I'm returning a string, I definitely have to have string right here. If I'm returning a character, I've got to have character here. Where does it get returned to? It gets returned to where it got called. So I call it here, it gets returned and assigned to here. Okay. So here's my return statement. Now, whenever I define a function, I have to have something called a function prototype. So main, when you run your program, the compiler starts here at this point. Okay, and it only looks at the things inside here. So because the function definition is down here, at the top here, I've got to let main know that there's a function down here, because main doesn't know that there's a function here. It won't know it. And the way that I'm going to let it know that is by creating my function prototype. And you've heard of the word prototype, right? So prototype is something that looks a lot like the thing, the real thing, but it doesn't work. That's the same thing here. So the prototype is going to be this. This here has a name. This here is called a function header. This is the header of the function. So if I take the header of the function and I paste it here, then this is my function prototype. And I could leave it like this and it will work, or I can delete the names of the variables. The names of the variables are not required. All that it requires is that you know the data type. But I can also leave it like this. I'm going to run it both ways so you can see that it works both ways. So right now, when I start and the compiler looks at the top and it includes all the code that is in these two libraries. So it includes all that code. So my program is no longer this tiny little thing. It's all this stuff that's in here plus all this. And then it looks at the prototype and it says, oh, okay, there's going to be a function, and the function name is random number generator, and this function should receive 2 integers, and this function returns an integer. So that's all that it does is it puts that into its memory, and then when you call the function in main, then it expects an integer and an integer, and it expects for it to return a value. And then also, if you have a function prototype, it also looks for the function definition, which is this part right here. So when we run this program, so right now it's not going to do anything because I didn't display anything. So let's display something. So we have int random num. We pass it a 1 and a 10. So why don't we display the random number? Random. Okay. So I run the program with a 1 and a 10, and it returns a 1, returns a 3. The number's down here, returns a 7, 9, etc. Okay, so now what I want to do is, let's ask the user, enter the lower and upper boundaries for the random number generator. And let's do one at a time. So enter the lower boundary for the random number generator, cin low, enter the upper boundary for a number generator, cin upper. Low and upper are going to be integers. So I'm just going to define them here, lower, low. Okay, it's better if I say lower and upper, that way they both match. Just makes me feel better. Okay, so lower and upper, and then here, instead of putting a 1 and a 10, I'm going to put lower, upper. Okay, so if I enter a 5 and a 10, the 5 will go to lower, the 10 will go to upper, then the 5 will go to lower bound, and the 10 will go to upper bound. These two variables will get used here, generate a random number, gets assigned to y, that number, boom, 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 gets assigned to random number here, and we output it here. Oh, there's a 0 there. Here's what we're going to do. I'm going to copy all this code And I'm going to close this, close that, and CPP.sh. Sometimes this compiler online doesn't work very well. Yeah, and it looks like, or it could be my internet, but no, my internet looks okay. Yeah, something's going on. So I can look at other compilers. Yeah, it says the site cannot be reached. So I can also look at online C++ compilers. I typically like this one, but let's just try this one. So we have there's our program, and we're going to click run. It says enter the lower boundary for the random number generator. Okay, so let's say that we want a number between 5 and 15. So the first time the number it gives us is 9. We run again and do 5 and 15 again. And now it gives us a 10. So it allows us to ask the user what they want the lower and upper bounds to be. Maybe a number between 100 and 500. 289. Okay? So again, when we look at this, we have, this is called a function prototype. This is terminology that you have to know, and it's in your PowerPoint slides. So this is the prototype. The prototype does not have to have the variable names defined. It just needs the data type. It's a prototype. Okay, it doesn't have to have everything. So if you run it, it still works. Just the compiler just needs to know what data types you're going to be entering. Then your prototype has to look, the prototype has to look just like the header. So you have integer, random number generator is the same. You got 2 integers. Give it whatever names you want. This is the header. The body of the function, this contains all the things that you want the function to do. And then here, this is a return value function. This here tells it that you're returning an integer. Where does it return to? Well, it returns to where you call it. So when you call it here, this is where it returns. And it gets assigned, that value gets assigned with the equal sign to this variable that you created. And then you get to display or do whatever else you want. This is what we call calling the function. This is where the function gets called. And typically we call a lot of the functions in main, or you call them within functions. There's some examples of some different functions that they've created. This talks about how we call a function. And then what we're going to do is we're going to look at void functions. So a void function, and then we'll look at how to pass variables by value and passing variables by reference. So I'm going to stop this to show how to do all that. No way, this is got that on there. Okay, so this is return value function, returns an integer. We have some functions that are not return value functions, and they can just be void. So it would be void. Let's say that I want to say display name. So this function is void, and it doesn't have any arguments either. And so what this function, if I wanted to call this function, I could, well, first let me define the function. So it's void, this is the prototype. So I take the semicolon off, I put open curly brace, close curly brace. Oh, this compiler puts the close curly brace for me, that's nice. And then inside I can just, it doesn't take any values, doesn't return anything. So all I can do is either write to a file or display something. I'm just going to display something. Cout, starting my program. Okay. And then I think I'm going to cout a new line. So when I run it, oh, I need to call the function. So I defined the function, but I haven't called it. So the next thing I want to do is call the function. So I'm going to stop the program, and right here before I call the random function, so anywhere before I call the random function, I'm going to go ahead and call the void function display name. So maybe I do it right here. Display name. And when I call this function, it's not returning anything, so I don't have to put an equal sign and a variable like d equals display name, because it doesn't return anything. And it doesn't take any value, so I don't put anything inside the parentheses. So when I run the program, it calls this function. So when it calls it, it displays starting my program. Then it couts enter the lower boundary. Oh gosh, let's see. Let's run it again because I typed a D by mistake there. Okay, so starting my program, enter 1, 10, and done. So this is a void function. Calling my void function, and without parameters. So what's a parameter? So parameter is this. Lower and upper are called parameters. You're passing two parameters to this function. This has no parameters. A void function can have a parameter. So let's say that you ask the user to enter their name. Enter your name. In name. So I can have a void function that takes a parameter. So this is or an argument. So we have name that gets passed to the function display name. So because I put name here, now I'm going to have to tell it that it's going to receive a name, and name is actually going to be a string. And I'm going to define name as a string. Enter the name, I enter the name, I pass it to here, it's going to go here. So I have to have string name. Here I just put string, here I give it the name of the variable. Now the name here doesn't have to be the same name as here, so it doesn't have to be called name. I could call it n if I wanted to. So what happens is in memory, you create a space for name. So you create a memory location for this variable. And then you go here and you create a memory location for this variable. So you actually have two memory locations. So this memory location gets assigned to this memory location. This is in a different place in the memory. This is in a different place in memory. So it's like an assignment. It's assigning name to n. It's like an equal sign. And then you could say starting, maybe fancy here, I'm going to put the name. So let's say that I enter the name Jeanette. Let's say starting Jeanette's program. Apostrophe S, Jeanette's program. Okay, so I'm going to enter the name Jeanette. It says starting Jeanette's program. So I grabbed the name here, Jeanette. I passed it to the function. It assigns it to n, and it displays it right here. And then I can generate a number. Let's see, between 20 and 100 gives me 49. So this is called a void function with one argument. This is called a value returning function, and we're passing it 2 arguments. Like we said earlier, names do not need to match. Okay, the rest of these slides are examples of more programs. Let's take a look at this example. This is a good one. So again, this is where we call the function get subtotal. Here we have quantity and item price. It gets passed to sold, and item price gets passed to cost per item. This is a memory location. This assigns it to sold. This is a separate memory location, so they don't have to have the same name. Totally separate memory locations. And then this function returns a double. So we're expecting that sales tax is defined as a double. It does some calculation here, and it returns the subtotal to this variable. Here's another example. We have so this is your function prototype. You can do it like example 1 or example 2. What they're showing here is that you can create your prototype with the variable names, or you can create the prototypes without the variable names. Now the reason I know it's a prototype and not a function header is because it has a semicolon. Remember, function prototypes have to have a semicolon, but function headers do not. So this is a function prototype, has a semicolon. Function header, no semicolon. Don't put one in there or your program's not going to run correctly. So let's run that with a semicolon. Actually, it gives you an error, so it won't even let you do it. So that's good. Glad that it won't let you do it. Okay. Going back to our PowerPoint. See if there's anything I left out. Here, in this program example, we have a function prototype. Again, amount, rate, and y can be left out of here. Here's our function definition. Defines the function. What does the function do? The function looks like it gets an amount and it returns a double, and it returns it to here to get balance, and assigns it to this variable. And then it looks like it's inside a loop. So this function gets called from year 1 to year 4. So it gets called for 4 years, and it iterates 4 times. So it gets called once, it gets called twice, it gets called 3 times. So the next thing that we're going to talk about is the scope and the lifetime of variables. So okay, so the scope of a variable means where is it that I can use this variable? Okay, so for example, in main, I have the variable random num, lower, upper, name. I can use these four variables only inside this main function. If I try to use the variable name here, it gives me an error. So if I put name there and I run it, it tells me that name is not defined. So error, name was not declared in this scope. So name is not declared in this scope. We cannot use it in this block of code. Name can only be used here in main. Let me go back to n. N can only be used in this scope. So if I try to cout n here, cout n, I'm going to get the same error. Or it's going to tell me that n is not defined. So it says n was not declared in this scope. So once again, n is not here, defined here, only these four. Okay, so you have to know what scope means. So the scope of name is the main function. The scope of n is the display name function. The scope of lower bound and upper bound is the random number generator function. That's the scope. The other thing that it talks about is a lifetime of the variable. Okay, the lifetime means that when I go here in string and I define string n, once I exit this function, this memory location is no longer available. I cannot get that memory location back. When I call this function, if I were to call this function twice, the memory location for n would be a different memory location. Okay, it's kind of like if I go rent a hotel room, right? If I rented this April, then I'm going to get hotel room number 3. And then when I leave that hotel room, I come back, I may or may not get the same hotel room. Most likely I will not. I will get a totally different one. So it's going to be a new location that I'm going to be in. And it could be, even with this string n, it could be that it gives me the same memory location, but most likely it's not going to be the same memory location. So that's what the lifetime means. So the lifetime of n is as long as you're inside display name. Once you exit display name n, it's dead. You can't get that memory location back. Now, the memory location of, the lifetime of these variables, the lifetime is the whole entire program. As long as the program is running, you will have access to these four variables, and they will be available inside the main function. So as long as the program is running, these four variables will be available, and they'll be available inside the main function. So the lifetime of these variables is the lifetime of the program. The lifetime of this variable is the lifetime of this function. Okay, so here they're talking about global versus local variables. I'm going to show you how to use a global variable, but I will tell you that it is very bad programming, bad a habit to use global variables, and companies will not allow you to use global variables. Now, they might have something global that they define to give to everybody in the company, but they will not allow for you to use global variables. I'm going to show you this, but I will take off points in programs where you use global variables unless the program specifically says use a global variable, then you use it. Most likely you will not have any programs unless I change something that I can't remember, but I don't have any programs where you use global variables. So here's how a global variable works. So this is local to this function, and is local to this function. These are local to the main function. A global variable is a variable that can be used in main. Oops. It can be used in this function, and it can be used in this function. So a global variable is one that any function can use. And you can see how that could be bad, because if you have programs that are pages and pages and pages long, and you define a global variable, then either you or some other programmer could change the value of that variable without knowing. So global variables are defined here. Again, do not use global variables. Integer, let's say that I call this global name. Oh, it's an integer. Oh, let me make it a string since it's a name. John. Okay. So this is a global name. So what that means is that I can see out global name here. Global name. And I'm just going to copy this. So I can use the variable there. I can use the variable here. I can use the variable here. So every function will understand this variable, will know and be able to access this variable. Okay, so we're here in main. We define our variables. We see out global name, so we see out John. We see out enter your name, so I'm going to enter Jeanette. Once I enter Jeanette, it calls display name. It goes over here. It outs the global name with this, which is John. Then it outs starting Jeanette's program, which is this line. Then it goes back here. The next thing it does is it asks me for a lower and an upper boundary. So I'm going to enter 4 and 66. After I enter the upper and lower boundary, it calls this function the random generator. When it goes into the random generator, it outs John again, which is the global name, and then it returns, the 29 gets returned and assigned to here, and it gets displayed here, the random number. So global variables are defined outside of main at the top, and we're discouraged you to use those only if the company allows you to use certain ones or they create them. Okay, really, really bad, because anywhere on here you could potentially mess up that global name. Okay, so I'm going to go ahead and delete the global name output statements, and I'm going to delete our global variable. So it says, declaring a variable as global can allow unintentional errors to occur. A function that should not have access to the variable inadvertently changes the variable's contents. So big no-no. You should avoid using global variables unless necessary. If more than one function needs to access the same variable, it is just better to create a local variable in one function and pass it to the other functions that need it. So we're just going to be passing variables to functions. We're not going to use any global variables. Okay, I think this is it as far as, as far as this chapter is concerned. So make sure in your review, functions are very, very important. They're hard for students to grasp. So what I want you to do is do something like I did here, where we entered some examples, create your functions, play with them, see what happens when you do certain things like declaring the same names or different names. Maybe make this a different data type and see what happens. So if I make this a string, but it's expecting an integer, what kind of error does it give me? The error says no match for operator. Operand types are int and string. So it's telling me no. This needs to be an integer. So just play with the functions. Really study the terms that I have here: function header, function definition, function prototype. Where do we call the function? Also, one thing that I don't that you won't see in the PowerPoint presentation is that when you have a function, in the function definition, you should have comments that have the name of the function. So the function name is, and this is going to depend how this looks. The way this looks over here, these comments depends from company to company how they want you to do it. But it would be something like this. So you would say what the name of the function is. You put what it does. So a description of the function. What does the function do? What is the name of the function? And then who wrote the function? So the author. So let's say that I wrote this function. I would put Jeanette Serrano-Correa, and I would put the date that I wrote it. Okay, so I would put the date here. And what that does is, let's say that I'm editing this program and I have a question about the function, or I'm just looking at the code, then I can go back to the person, if the person still works there, and ask them questions about the function. Okay, so we typically have the name of the function, the random number generator, description of what the function does, the author, and the date. Okay, thank you guys.